Today we are going to review some exponent rules. So we're going to look at how we combine terms that have exponents. The first exponent rule we're going to review is called the product of powers. This just means that if we are multiplying terms that have the same base, like what we see here in our example, A and A, if we're multiplying terms that have the same base, we combine them by adding their exponents. So we're going to look at a few examples on page 8. So we've got 3x to the 6th times 5x squared. Now 3 and 5 I multiply the same way that we have always multiplied 3 and 5. So 3 times 5 gives me 15. And then for my variables, my terms that have the exponents, since I have x and x, they have the same base, we can combine them. We're going to combine them by adding their exponents. So 6 plus 2 would be 8. Okay, so I would have 15x to the 8th. And again, I got that by adding the exponents. So my final answer here would be 15x to the 8th. For example 2 here, same idea. My numbers, I'm going to multiply. -4 times 3 is -12. And then my variables that are the same, so A, I can combine. 3 plus 2 would be 5. And then my B, I can combine. So this would be b to the first. If I don't see an exponent, it's 1. 1 plus 5 is 6. So there would be my simplified version. We're going to do a couple more on page 8. Simplify our expression here. So we're multiplying a bunch of x terms together. That means that we're going to add all of their exponents. Since I don't see an exponent on this first guy, that means that it's 1, and then 2, and then 4. So 1 plus 2 plus 4 is 7. So this would simplify to x to the 7th. For number 2, I've got -x cubed times -x to the 4th. I could think of this as being a -1 and a -1. -1 times -1 would be +1. So you can write the 1 or not. But the important thing is that this would now be positive for my final answer. And then I'll have x to the 3 plus 4 is 7, x to the 7th. Let's hop down to number 5. And same idea, -3 times 2 is -6. And then I've got some j's. So 2 plus 1 would be 3. So I have j cubed. And then I've got some k's. 4 plus 6 is 10. So -6j cubed, k to the 10th. On the next page, on page 9, we're going to review some more exponent rules. This time we're going to look at when we have something with an exponent, we raise it to a power, or when I have multiplication inside parentheses and that whole thing, that whole quantity is raised to a power. So when I have a power to a power, we multiply those exponents. So if I have something with an exponent already and I'm raising it to another power, multiply those exponents to simplify. If I have something, some quantity that I'm multiplying together that I'm raising to a power, each of those terms get that exponent. Now I want you to notice this is a times b. If we had a plus b, this would be something different, okay? So this does not mean this, okay? We talked about this in our polynomials unit when we talked about distribution. This with the addition is not the same as if it's multiplied, okay? So we're gonna focus on if we're multiplying terms. So for our first example here at the top of page 9, I've got this quantity to the 3rd power, and then I've got this second term to the 4th power. So the first thing I'm going to do is distribute those exponents in. So this would be -2 cubed times a cubed times b squared cubed. Notice I put each of these in parentheses, especially if I'm raising a negative number to a power. I want to make sure that I account for that negative sign when I take it to the power. And then I have a squared to the 4th power. -2 cubed is -8. And then a cubed is just a cubed. B to the 2nd to the 3rd, I'm going to multiply those and I would get b to the 6th, right? That's 2 times 3. And then over here, a to the 2nd to the 4th would be a to the 8th. 2 times 4 is 8. The last thing I want to do here is combine my like terms. So I'm multiplying things that have the same base. So we add their exponents like we did on the last page. So I would have -8 times a to the 11th, 3 plus 8 is 11, times b to the 6th. And there's my final answer. We'll do a few more examples on this page. So if we take a look at number 9, I've got the quantity 4x that's being squared. So that means we've got 4 squared and x squared. And then we're multiplying that by b cubed. 4 squared is 16. And then I've got x squared, b cubed. I have no like terms to combine there. That's not going to get any simpler than it is right now. If we hop down to number 13, I've got 2 quantities being raised to power. So I'm going to start by distributing that power in. So this would be -3 squared, and then j squared squared, and then k cubed squared. And then here I have 2 cubed, and then j squared cubed, and then k cubed. So let's start simplifying here. -3 squared is 9. J to the second, multiply those, I get j to the 4th. And then k to the 3rd to the 2nd. This would give me 3 times 2 is 6, so k to the 6th. And then I'm still multiplying. 2 to the 3rd power would be 8. This would be j to the 6th. And then k cubed. So I've got this term times this term. I've got a little more combining I can do. 9 times 8 is 72. And then I've got j to the 4th and j to the 6th. Now I'm going to add those exponents since I'm multiplying all these terms together. So that'd be j to the 10th. And then k, 6 plus 3 would be 9, k to the 9th. The last problem we're going to look at on page 9 is number 14. So this first quantity is being cubed. The second quantity is being squared. Just to give myself a little more room, I'm going to start writing up here. So I've got 25 cubed, and then a squared cubed, and then b cubed. And then I've got 1/5 squared, and then a squared, b squared, and f squared. So let's simplify these numbers here. 25 cubed, that would be 15,625. A squared cubed, multiply your exponents here, you get a to the 6th. And then this is b cubed. And then we're multiplying by this guy. When I take a fraction to a power, I can separate that power between the top and the bottom. So on the top, 1 squared is 1. On the bottom, 5 squared is 25. And then again, a squared, b squared, f squared. So now let's combine our like terms. I'm going to start by multiplying my numbers. So that's my 15,000 number here and my 1/25 here. What I'm essentially doing is taking this number and dividing by 25. So that gives me 625. And then a to the 6th times a squared would be a to the 8th. B cubed times b squared would be b to the 5th. We're adding those exponents. And then f squared, my only f term there. So when we have a power raised to a power, like we had here, we multiply those. When I have multiple terms inside parentheses, the power applies to all of them. And again, when I've got things of the same base that I'm multiplying, we add their exponents. We have just a few more exponent rules that we're going to look at for today. So turn to page 10 for me. And we're going to look at when we're dividing terms that have an exponent. So when I have the same base and I'm dividing, we subtract their exponents. A couple pages ago, we said when we have the same base and we're multiplying, we add the exponents. So here when we're dividing, we subtract their exponents. And then if I've got a power, we actually just used this rule, a power outside of some division, that power applies to both the top and the bottom. So let's take a look at our top example here. I've got A's on top and bottom and B's on top and bottom. So this is telling me if we have A to the fourth divided by A, that we're going to take 4 minus 1. That would give us A cubed. Now we have B to the 7th over B squared. I would take 7 minus 2, and that would give me B to the 5th. When we're subtracting exponents, I generally say that we take big minus little and it sticks where the bigger exponent was. So 4 minus 1, it sticks on top. We can think of all of this as sort of being over 1. And then the same with our B. 7 minus 2, 7 big, minus 2 is 5, sticks on top since that's where that bigger exponent was to begin with. For our second example, we could approach this one of two ways. We could start by simplifying inside and then distribute the exponent, or we could distribute the exponent first. I'm going to choose to simplify inside first. That way the numbers I work with when I multiply are a little bit smaller. So the only thing that I see on top and on bottom are my b's. So 5 minus 2 would be b cubed. So I have 2a cubed, b cubed, and it stays on top since that's where the bigger exponent was, over 3. And now I'm taking all of this to the third power. So this would be 2 cubed, a cubed to the third power, b cubed to the third power, over 3 cubed. When I simplify 2 cubes, that's 8. And then this would be a to the 9th, since I would have 3 times 3. And then b to the 9th, since again I have 3 times 3. And then on the bottom, 3 cubed is 27. So there's my simplified expression there. We're going to look at just a few more examples on page 10. So we take a look at 17. I've got x on top and bottom. This time my exponents are the same. So big minus little kind of doesn't mean anything here. It's just 5 minus 5. 5 minus 5 is 0. So that means I have no more x's to worry about. If we thought about this as sort of a reducing problem, this would be like 2 over 2, which just reduces to 1. I don't have any 2's left. So x over 5, x to the 5th, I should say, over x to the 5th, that's going to reduce completely. And then I've got y cubed over y squared. 3 minus 2 is 1. That leaves me with y to the 1st, or just plain old y. For number 20, I've got some division to a power. Again, I'm going to start by reducing what I can inside of the division. So I've got a on top and a on bottom. 2 minus 1 would be 1. So this would be 2a, or a to the 1st if you'd rather, b, all cubed. So that gives me 2 cubed, a cubed, b cubed. One more step to simplify. 2 cubed is 8, so I have 8, a cubed, b cubed. And then the last problem we're going to look at together for today is number 21. So again, I'm going to reduce what I can inside parentheses to start. The 4 and the 3 don't reduce, so I'm going to leave those as they are for now. The p's I can reduce. 4 minus 2 is 2, so I have p squared on top. And then 4 minus 2 again is 2, so I have r squared also on top. And then I'm going to raise all of this to the third power. So I would have 4 cubed, and then p squared cubed, r squared cubed, all over 3 cubed. So now as I continue to simplify, 4 cubed is 64. And then this would be p to the 6th, r to the 6th, over 27. Okay, so that's a review of our exponent rules. What I would like you to do now is finish the problems that we skipped from pages 8, 9, and 10. So we did some examples on each of those pages. You're going to go back and now do the examples that we skipped.